Okay guys, let's begin the discussion over the questions. The first question says limit x tends to 0 of this expression is what? Now see, the moment you see 1 minus cos 5x and in the denominator you have 1 minus cos square x, right? So in the numerator you can very easily dissolve this into, this is 1 minus cos x, you know this, how do we expand this? This is 1 plus cos x plus cos square x plus cos cube x plus cos to the power 4x whole upon 1 minus cos square x is what? 1 minus cos x into 1 plus cos x. Very clearly this gets cancelled out. As x approaches 0, we have cos x approaches 1. So limit x tends to 0 of 1 is 1. Limit x tends to 0 of cos x is 1. Limit x tends to 0 of cos x whole square is limit x tends to 0 of cos x then whole square, which is 1 square, which is 1. This is 1 cube, which is 1. This is 1 to the power 4, which is 1. Whole upon 1 plus 1, that is 2. So you basically get 5 by 2 as your very limit. Clear? Moving on to the next question, we have limit x tends to 0 of tan x minus sin x whole upon x cube. Let's try to see what this limit turns out to be. Tan x minus sin x. Okay, so tan x minus sin x whole upon x cube. Okay, so this becomes sin x upon cos x minus sin x whole upon x cube. Limit x tends to 0. I'm just dissolving everything in terms of sine and cos. So this lands you to the step sin x minus sin x cos x whole upon cos x into x cube. Fine. Next step, you can see from the numerator I can extract out sine common, so I get sin x common and inside I have 1 minus cos x and in the denominator I have cos x into x cube. And clearly this is limit x tends to 0. Now what I do is I basically distribute this limit to simplify my expression. I get sin x upon cos x and I basically put x cos x here. 2 x's are remaining, I just keep it as another expression which is 1 minus cos x upon x square, which is 2 sine square x by 2 upon x square. Now you know that limit x tends to 0, sine x by 2 upon x by 2 is 1. I want x by 2, so I basically divide by 4 and multiply by 4. So that I get x by 2 whole square and here I have sine x by 2 whole square. So here basically this turns out to be limit x tends to 0. Sin x upon cos x is tan x by x into 2 by 4 comes out, that is 1 by 2 comes out. It's a constant independent of x. Then you have sin x by 2 upon x by 2 whole square. You know square is a continuous function. So limit of this square is square of limit of sin x by 2 upon x by 2, which is square of 1, which is 1. So this you know is 1 into 1 by 2 into this is 1 square, which is 1. So your answer is nothing but 1 by 2. Clear? Moving on to the next question, we have what is the value of this particular limit? Now here if you carefully observe, the main expression which is playing the role is 1 plus x whole to the power 1 by x. So let's catch hold of that term and then try to resolve the entire expression on the basis of 1 plus x whole to the power 1 by x. Now here if I catch hold of this complete term, I am saying let y be equal to 1 plus x whole to the power 1 by x. You know, in order to bring this 1 by x ahead, I need to bring log into picture. So I bring log into picture, I I say that log y is 1 by x log of 1 plus x. This is actually log of 1 plus x whole to the power 1 by x, which becomes 1 by x log 1 plus x. Very well versed with the expansion of log of 1 plus x. What is it? It is x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 and so on. Just multiply this inside, you get x upon x, which is 1, minus x upon 2 plus x square upon 3 minus x cube upon 4 plus and so on. This is nothing but log y. So y will be equal to what? Y will be equal to e to the power 1 minus x by 2 plus x square by 3 minus x cube by 4 and so on. Now e to the power 1 plus minus x by 2 and so on can be basically resolved into e to the power 1 into e to the power minus x by 2 plus x square by 3 minus x cube by 4 and so on. Here now I am going to use the expansion of e to the power something which is 1 plus that something plus that something whole square by 2 factorial and so on. Don't forget, I am interested in limit x tends to 0 of this expression, okay? Don't forget that. Okay, coming back, how can I resolve this? This becomes e minus ex by 2 plus ex square by 3 minus ex cube by 4 plus and so on, and then you have e again. So e by 2 factorial. So this is the next term, another term. This is e by 2 factorial. Inside you have minus x by 2 plus x square by 2 minus x cube by 3 and so on whole square. So from here you can take out x common. When you take out x common throughout, actually x square comes out. And inside you are left with minus 1 by 2 plus x by, this is minus x by 2, this is 3 and this is 4. So you are left with minus 1 by 2 plus x square by x by 3 minus x square by 4 and so on. Now you can see I can write this as y minus e plus ex by 2 equals, from here you are left ex square by 3 and so on, then again ex square by 2 factorial into all of this. So I can see that ex square is coming out common. I am left with 1 by 3 minus x by 4 and so on, plus also I am left with ex square common, so I am left with 1 by 2 factorial. So this is one thing, complete ex square is coming out common. I am left with 1 by 2 factorial times, this is common, okay, so minus 1 by 2 plus x by 3 minus x square by 4 and so on. Okay. So from here you can see I can just bring x square over here. This becomes y minus e plus ex by 2 whole upon x square. Okay. And here you are left with e into all of this. Right, x square only I have extracted to bring it down. Now that I have extracted x square to bring it down, I want, this is y minus e plus ex by 2 whole upon x square. So that I have got on the left hand side, see, y minus e plus ex by 2 whole upon x square. I am just interested in the limit x tends to 0, y is nothing but 1 plus x whole to the power 1 by x. Let me replace that by the expression y minus e plus 1 by 2 ex whole upon x square. When you apply limit x tends to 0 on the right hand side, it is e into all of this. Limit x tends to 0 makes all of this 0. You are just left with 1 by 3. Here it is square of this, all this is square, right? So square gets carried forward. Here when you apply, all these terms become 0. You are just left with minus 1 by 2 whole square, which is 1 by 4 into 1 by 2 factorial, which is 1 by 8. So you're just left with e multiplied by 1 by 3 plus 1 by 8. Yes, just left with e multiplied by 1 by 3 plus 1 by 8, because rest all the terms contain x. So when x approaches 0, all those terms become 0. And 0 plus anything is that thing itself. So this gives you 11 by 24e. So your answer is option number A. Clear? Moving on to the next question, we have a paragraph question which is giving us the description of a certain definition. It is saying that f, g and h are functions which have a common domain D, and fx is sandwiched between gx and hx. If limit of hx and gx at a certain point is same, then that itself is the limit of fx also at that point. This is known as sandwich theorem. Using this result, compute the following limits. The first limit we need to compute is this. Now, mind it that this is playing the role of fx. This is playing the role of fx. I need to find gx and hx, which basically sandwich my fx. So for that, my concepts about the mod function and square root function should be at the tip of my fingers. I know that under root of, if I talk about the denominator, x to the power 4 plus 4x square plus 7. Very clearly I know that this is strictly greater than 1. Right? Now over here, if this is strictly greater than 1, also therefore it means 1 upon under root x to the power 4 plus 4x square plus 7 is less than 1. Mod x, you know, is greater than equal to 0 always. So now I can say, and this is also greater than equal to 0 always. So I can say mod x upon under root x to the power 4 plus 4x square plus 7 is less than equal to, you can just put equal to mod x and greater than equal to 0. Right? Now this is fx, this is the constant function gx, and this is hx. You need to compute limit x tends to 0 of fx. Limit x tends to 0 of 0 is 0. Obviously, it's a constant function 0. Limit x tends to 0 of mod x is what? What is limit x tends to 0 of mod x? It's very simple. Limit x tends to 0 of mod x. Mod is a continuous function. Limit x tends to 0 of mod x is mod of limit x tends to 0 of x, which is mod 0, which is 0. So, this approaches to 0, this approaches to 0. By sandwich theorem, even this approaches to 0 as x approaches 0. So, the limit is basically 0. Moving on to the next part, we have limit x to the power 4 sine 1 by 3 root x. Now, this is pretty easy again. Here, if you talk about this function as fx, you know that sine of any argument is less than equal to 1 and greater than equal to minus 1. X to the power 4, you know, is a non-negative function. So I can say x to the power 4 times sine of 1 by 3 root x is less than equal to x to the power 4 and greater than equal to minus x to the power 4. Now this is playing the role of gx, this is playing the role of hx, and that's my fx. Limit x tends to 0 of x to the power 4, you know it is 0, this approach is 0. Also minus 0 is 0 only, so this is also going to approach to 0. Again, the answer is 0. Moving to the next, what we have, let's see. We have this particular function given to us. Again, at 0, we need to evaluate its limit. Let's talk about the limit of this function using the sandwich theorem. Here, if I talk about taking out e to the power 1 by x common, I will be left with 1 minus e to the power minus 2 by x. From the denominator also, if I take out e to the power 1 by x common, I will be left with 1 plus e to the power minus 2 by x. These are non-zero expressions, I can cancel them. I know this is always greater than equal to 0 and less than equal to 1. Right? Now x square is multiplied, so x square multiplied by this is less than equal to x square and greater than equal to 0 into x square. This approaches to 0. I know x square approaches to 0 as x approaches 0. Again, by sandwich theorem, this approaches to 0. So, yes, limit extends to 0 definitely exists and it is equal to 0. Moving to the next question, we have set of all points where the function mod x into sine x is differentiable is what? Okay, so fx is mod x into sine x. If I talk about what it actually turns out to be, it depends upon x's positive or negative. When x is non-negative, mod x is x, so you get x sine x. When x is negative, mod x is minus x, so you get minus x sine x. Clear? After this, you need to evaluate the differentiability of this function. If I talk about this particular range, x is non-negative and x is negative, of course these two functions are differentiable. Fine, but the problematic point is only 0. If at 0 it turns out to be differentiable, I am going to say that this function is everywhere differentiable. Because it is differentiable after 0, it is differentiable before 0. At 0, we need to evaluate about its differentiability. So, let us talk about its differentiability at x equals 0. Fine, left hand derivative, right hand derivative, let us see if they come out to be equal or not. Left hand derivative of f at 0, it is limit h tends to 0 from the negative, f of 0 minus h minus f of 0 whole upon minus h. Now f of 0 minus h before 0, so it is minus h sine h. F of 0 is 0 into 0, which is 0, whole upon minus h, limit h tends to 0. Fine. Now over here, basically this becomes limit h tends to 0 sine h, which is 0. Talking about the right hand derivative, what does that turn out to be? Let's see. Limit h tends to 0, f of 0 plus h minus f of 0 whole upon h, which is f of 0 plus h is h sine h. Again, f of 0 is 0 whole upon h. So, you are just left with again limit h tends to 0 sine h, which is 0. So, you are getting that yes, the function is differentiable at 0 also, before 0 also, after 0 also. So, basically it is differentiable everywhere. The answer is on the entire real line it is differentiable, which is minus infinity to infinity open interval. Okay guys, so let us talk about this question. We have y square equals px. It is a polynomial of degree 3, then twice of d by dx of y cube or into d square y by dx square is equal to what? Let us see, if y square is px, 2y y1 is p dash x. So obviously 2y1 is p dash x by 2, p dash x by y, right. Differentiate once again, so you get 2y2 equals second number into differentiation of the first minus first into differentiation of second upon second number whole square. y1 is basically p dash x upon 2y. So you get y into p double dash x minus p dash x. y1 is, what did I say? y1 is p dash x upon 2y whole upon y square. So now you have 2y square p double dash x minus p dash x whole square whole upon 2y cube. This is equal to 2y2. Fine, this is y square, this is y2. So 2 cancels out. You are left with y2 into y cube. You are left with y2 into y cube equals 1 by 2. Or let me just keep this 2 over here. This is 1 by 2 times 2 y square into p double dash x. So I have just This is 2y2 y cube, 1 by 2 times this. So what is y square? Y square is given as px. This is p double dash x minus p dash x whole square. Right? 1 by 2 is throughout, but this 2 is only with this term. Now, 2y2 y cube. When I talk about d by dx of, then you have y cube, and this is y2. y2 is what? D square y by dx square. I am saying this is 1 by 2. Inside you have what? This becomes twice of px into p triple dash x plus p double dash x into p dash x. So you basically get twice of this plus twice of this minus 2p dash x p double dash x. So 2p dash x p double dash x minus 2p dash x p double dash x, you are just left with px into p triple dash x. So your answer of twice of d by dx of this is actually px into p triple dash x as your answer. Fine. So your correct option is px into p triple dash x. Moving on to the next, we have f is a differentiable function satisfying f of x plus y is fx plus x f of y plus xy into x plus y for all x and y in the collection of all reals. F dash 0 is 2, then what happens next? Okay. Now here this equation is given to you of f of x plus y. Differentiate with respect to x keeping y constant. What you get is f dash of x plus y is equal to f dash x. Then f of y is a function of y completely, it's a constant considered, so it will be 0, the differentiation. Then y is considered constant, so x into 1 plus x plus y into 1. It is first number into d by dx of second number, which is second number is x plus y, so d by dx of x plus y is 1. Then plus x plus y into d by dx of x, which is 1. So you get f dash x plus xy plus y into x plus y. This is f dash of x plus y. Fine. Now if you put x equals 0, this is true for all xy in the collection of all reals. So in particular it is also true for y equals 0 or x equals 0. So you get f dash y equals f dash 0 plus, so y, and x is 0, so you get y square. So f dash 0 is given to be 2, so you get 2 plus y square. So basically f of y turns out to be 2y plus y cube plus c. Right? The moment you get 2y plus y cube plus c, now if you put x equals 0 and y equals 0 in the given equation, this one, you get f of 0 plus 0, which is f of 0 equals f of 0 plus f of 0 plus 0. So it is twice of f of 0, which eventually gives you that f of 0 is 0. If f of 0 is 0, in place of y, if you put 0, you get c equals 0. So you get f of y is 2y plus y cube. It is 2y plus y cube. Take out y common, you are left with 2 plus y square. If you put this equal to 0, what are the roots coming out to be? 0 and plus minus iota root 2, isn't it? Because it will be y square equals minus 2, y equals plus minus root 2 iota. So your answer is that f of y is a polynomial of degree 3. It is thrice differentiable, it is a polynomial function, and it is of degree 3 whose roots are 0 and plus minus iota root 2. Clear? Moving on to the next, we have f and g are differentiable functions such that f dash x is twice of gx and g dash x is minus fx. Let tx be this function, then t dash x is equal to what? It's pretty easy. Let's try to understand. Tx is defined as fx whole square minus gx whole square. Clear? T dash x becomes twice of fx into f dash x minus twice of gx into g dash x. F dash x is given to be twice of gx minus g dash x is given to be minus fx. Okay. So 2 times fx into gx can come out common. You are left with 2 plus 1, which is 3. 3 into 2 gives you 6. So you have 6fx gx as your very answer. Clear? Revise all the questions nicely. That's it from my side. Thank you.